Hello. In this video, we are going to look at calculating what is needed for an IV push medication. We see the order for this medication is 300 milligrams administered as an IV push. And we see a label, we see directions for the intravenous injection, which is an IV push. And so down below all of this information, we see our first question, which is how many milliliters of the med will you need? So here you can use dimensional analysis, and that's my first strategy that I'll show you. So in dimensional analysis, I always start with the order, which in this case is 300 milligrams, and I put that over 1. Based off of the label, I see that the strength of the medication is 300 milligrams, so I'll put that in the denominator to cancel the label of milligrams per every 2 mL. And so based on this, I can do that math in my head. I see the 300s cancel, and the answer here is 2 mL. The other way that we could do this exact same problem is with that nursing formula. So doctor's order over what we have times the quantity. So the doctor's order here is 300 milligrams. What we have on hand is 300 milligrams, and that is in the quantity of 2 mL. And you can see that that would lead us to the exact same answer of 2 mL of this medication. Next, it asks us how many milliliters of normal saline should you add to the med? Well, in order to figure that out, I'm going to have to read all of the fine print here. Now, I have read this before, so if you need to pause the video, you certainly may. But as I read through all of this, I really start focusing in right here where I see this word dilute. So we're to dilute the medication, and I keep reading, with the sodium chloride injection. So that is normal saline there because I recognize that that 0.9% is the same as normal saline, or another compatible IV solution. And here comes the key information, to a total volume of 20 milliliters. All right, so I need a total of 20. In my syringe. In the first part of this problem, I already calculated that I need 2 milliliters of the medication. So I'm going to take 20 and subtract 2, and that gives me 18 milliliters of normal saline. Now, I want you to notice that this is very different than the previous problem that we have done in our content guide. The previous problem told us to add 10 mL. This problem says a total of 20 mL. So because the total amount in the syringe is to be 20, I will only need 18 mL of normal saline because I already have 2 mL of medication. All of that comes into play with the next question, but before I can answer this, I am going to have to do some reading. So it says, at what milliliter per minute rate should the med be administered? Well, I need to know how many minutes. I know how many milliliters, but I don't know the minutes. So it tells me up here, and inject, so I'm reading here at the end, over a period not less than 5 minutes. So I'm going to give this injection over 5 minutes. So milliliters, well, there are 20 in the syringe. Minutes, we read that it must be at least 5, and we chose to use 5. So if I divide this out, 20 milliliters over 5 minutes would be a rate of 4 milliliters per minute. And then in order to push this, we are to figure out the milliliters per 15 seconds. We know that 15 seconds is 1/4 of a minute. And so we can take the rate that we just calculated and divide that by 4, because we want 1/4 of it. And so 4 divided by 4 is 1. So that gives us 1 milliliter every 15 seconds. Now, in class, we have worked with the syringes and seen how to push them. I did not give us a 20 milliliter syringe, but I do have an image of one. So we're going to take a look at the image. So here is the 20 milliliter syringe. And based on what we calculated, we would originally put in, up here we pull the plunger down and we put in 2 mLs up here, of our medication, and then the rest of this would be normal saline, so our syringe would be full right down here to the 20 ml line. We calculated that we should do or administer 1 ml per 15 seconds. And so if I look at the way the syringe is labeled, here's 15, so 16, 17, 18, 19, 20. Each of these calibration lines is 1 ml. So we should be pushing this far from one calibration line to the next every 15 seconds. And so that is our full IV push problem. We calculated how much medication, how much time, and down to the 15-second rate.